Um, so the torque due to a force then, about, if you remember the formula um, in math or in physics, torque is R, the position vector, crossed with with the force vector.
Yes.
And R is the position vector from the origin, like if this is, to the point x, y, z, to the point. So like if the point 152 is somewhere here, no, this is your position vector. Okay. So technically, this vector r, no, because we have the coordinates of the origin 0, 0, 0, vector r will be the same. It's invariant. The coordinates for that point are themselves the coordinates of the vector.
Right. Yeah.
And we know that f is just 2 minus 3, 1. And now we can go ahead to find the torque. We can apply the cross product. You still remember the cross product?
Yeah. Oh yeah, that would take care of the magnitude also, because it's the
right? Minus 3, 1. And we take the magnitude of this matrix. So we line up the ijk as the first row, the vector r as the second row, and the force f as the third row. And from there we take the determinant of the 3 by 3 matrix. So on the first component I, we hide the column and the a row that I is in, right? So we end up
3 by 3.
we end up with this matrix here.
Isn't it the
when we hide the I?
um,
because you know you're working in 3 dimensions here, and the torque is this is a 3 by 3 matrix for the cross product.
not a 3 by 2?
Mm-mm. 3 by 3. I forgot. And so we get, oops, yeah. And now we continue by taking the determinant of that highlighted matrix, which is 5 times 1 minus 3 times 2. So that's the first component. And then we go to the next component, so it goes minus j due to the sign of the cofactors. Yeah? And now, when we hide the row and the column that the j is in, we end up with this and this. Yeah?
Yeah. Yeah.
And so this will be 1 times 1 minus, no? So we take the determinant of that matrix minus 2 times 2. And that is the j component.
I mean, you get the
And then,
j component, that would be it, right?
yeah, and then,
Oh, so yeah, that's what I was going to do. It's just,
and then we go to the k component plus, and we hide, yeah, we hide this, yeah. So we get, do you understand what I'm saying? We hide the row and the column that the k is in.
Yeah,
So,
I get it.
so we get this.
That's what I was doing. I just didn't put the K, the IJK in the matrix. I was just gonna put them.
Yeah, so we get 1 times minus 3 minus 2 times 5. So then that tells us it's 5 plus 6 is 11i. So this guy here is the torque. 11i. And then here we get 1 minus 2 is minus 1. So plus j. And minus 3 minus 10 is minus 13k. So this here is our desired torque.
Was there a symbol for unit vector, or is it just? Oh,
The IJK, no?
yeah. Or is it just?
And so this is the torque. Yeah. Now for part B, it's saying the torque about y-axis. Whichever is closer to you. I can do either Northridge or North Hollywood today. Let me know what works better for you. Yeah? Already? So, got it done?